Hello everyone, this is Aditya Sharma. Welcome back to yet another tutorial video. In this video, we are going to discuss the fundamentals of Hadoop. So fasten your seatbelts as we are about to dive deep into the ocean of Hadoop. Before we proceed, let's have a keen look at the topics that we are going to discuss in this tutorial. We will start the proceedings with introduction to Hadoop. Then we will head into its history. Later, we will discuss the key features of Hadoop. Then we will understand the main goals of Hadoop, that is the Hadoop distributed file system. Later we will move to the distributed file system, followed by the components of Hadoop. Last but not the least, we will discuss about the Hadoop ecosystem. So let's get started with it. Hadoop is an Apache open source framework written in Java that allows the distributed processing of large datasets across clusters of computers. Using simple programming models, the Hadoop framework application works in an environment that provides the distributed storage and computation across clusters of computers. In simple words, Hadoop is basically an open source software programming framework for providing a large amount of data and performing the computation. Before heading into the features of Hadoop, it's important to understand its history. Hadoop was started with Doug Cutting and Mike Carfella in the year 2002 when they both started to work at Apache Nudge project. In 2003, they came across a paper that described the architecture of Hadoop's distributed file system using Google called HDFS or Google File System. It was published by Google for storing the large data sets. In 2006, Doug Cutting joined Yahoo along with the Nudge project. So at Yahoo, firstly he separated the distributed computing parts from Nudge and formed a new project called Hadoop. He gave the name Hadoop because it was the name of a yellow toy elephant which was owned by his son. In January 2008, Yahoo released Hadoop as an open source project to ASF or the Apache Software Foundation. Finally, in July 2008, Apache Software Foundation successfully tested a 4,000 node cluster using Hadoop. This given slide displays the set of famous multinational companies and tech giants using the Hadoop and its architecture. This list includes Amazon, Google, Facebook, Yahoo, New York Times, Microsoft, Rackspace, and many more. Now let us discuss the important features of Hadoop. The biggest and the most fundamental features of Hadoop is data replication. To ensure there is no data loss, Hadoop stores and maintains 3 copies of data in separate slave files. This is termed as the replication factor. Hadoop is basically a highly scalable and robust platform that can store hundreds of nodes simultaneously. This feature helps to store data across large clusters of nodes and ensures there is no fault tolerance and reliability. Due to its distributed manner, the data can be parallelly processed in clusters of nodes. This generates high throughput in return. Also, with HDFS, computation happens on the data nodes, where the data resides rather than moving the data to where the computational unit is. The next topic in our bucket list is Hadoop clusters. A Hadoop cluster is a special type of computational cluster that is designed specifically for storing and analyzing the huge amounts of unstructured data in a distributed computing environment. Such clusters run Hadoop's open source distributed processing software on low cost commodity computers. As you can see on the screen, this image idealistically represents how a Hadoop cluster actually looks like. Typically, one machine in the cluster is designated as the name node and another machine as the job tracker. These are the masters. The rest of the machines in the cluster acts as both data node and task tracker. These are the slaves. Hadoop clusters are often referred to as shared nothing systems because the only thing that is shared between nodes is the network that connects them. Now let us understand the goals of Hadoop Distributed File System, or commonly known as HDFS. Firstly, it provides faster recoverability from hardware failures. One Hadoop instance may consist of thousands of servers. Thus, failure of at least one server can prove to be fatal. HDFS has been built to detect faults and automatically recover it quickly. Secondly, HDFS is intended more for batch processing. This means the emphasis is for high data throughput rates, which accommodates streaming access to datasets. HDFS accommodates applications that have datasets typically gigabytes to terabytes in size. Thus, HDFS provides high aggregate data bandwidth. Last but not the least is portability. HDFS is designed to be portable across multiple hardware platforms and to be portable and compatible with multiple operating systems. Now, let us discuss the components of Hadoop. Firstly, we have HDFS, or the Hadoop Distributed File System. That is a distributed file system that handles large data sets running on commodity hardwares. Then we have MapReduce framework, which helps the Java programs to do the parallel computation and parallel processing on data using key value pairs. We also have Yarn, or so-called yet another resource navigator, that combines a central resource manager with containers, node level agents in individual cluster nodes. Lastly, we have crucial Hadoop libraries made in Java that are indeed used by other Hadoop modules. I have listed a few Hadoop libraries down below. You can check them out too. The last topic in our bucket list is the ecosystem of Hadoop. The given picture illustrates all the set of crucial and fundamental Hadoop frameworks. This ecosystem includes MapReduce, Drill, Hadoop Pig, HBase or NoSQL database, Oozie, Mahout, Spark, Zookeeper, Yarn, HDFS, etc. This concludes our bucket list of fundamental topics and domains of Hadoop. I hope you understood a lot from this tutorial. In case you did so, do consider dropping your suggestions in the comments down below. See you next time. Until then, thanks for watching and have a good day.